So our last section in Chapter 10, we're going to look at areas of circles and sectors. So areas of circles is something I'm sure that you've seen before, so we'll go through that pretty quickly, but then a sector of a circle is probably something new for you. So we'll wrap up with sectors and then another new term we call segments. But as we get jumped in here, we're just going to go ahead and throw out that area of a circle formula. Area is equal to pi r squared. Not something you have to have memorized, although it would be good to kind of work on memorizing that, but just something you want to make sure you're familiar with. So our first example here, our first problem, we want to find the area of the circular wrestling mat at the right here. So as always, I like to start by writing down my area formula, area equals pi r squared, and figure out which variables I need to know to use this formula. I need to know my radius. If I look at my picture, notice this white line all the way across the center, that's the diameter, vocab term from the last section, and that's equal to 32 feet. So using what we know about diameters and radiuses, if it's radius is half of the diameter. So if my diameter is 32, that means my radius has to be 16, or half of 32. Now that I have my radius, I can go ahead and plug it into my area formula. Area equals pi r is 16 squared. Now, pay attention in your homework to how they ask for your answer. If they say leave it in terms of pi, simplify everything but the pi. In this case, everything but pi is 16. 16 squared is 256. So we could say 256 pi feet squared. Since they don't specify, but we are talking about an application here, we're looking at the area of a mat, we're probably more likely going to actually want this answer rounded. Let's just say to the nearest foot. So 256 times pi gives us about 804 square feet. Again, we are still talking area, so we want to make sure we use units squared. That should be reviewed for you. If you need more help with area, please let me know. Now, moving on to a new term for us, it's what we call a sector. And a sector of a circle is a region bounded by an arc of the circle and the two radii to the arc's endpoints. So if we see here, we have a sector RPS. It's this shaded in portion here. I like to think of a sector as kind of like a slice of pizza. It's like taking out that piece of pizza. We're talking about how much area is there in that piece of pizza. And to find our area, we have a formula here. It says the area of the sector of a circle is the product of the ratio of the measurement of the arc over 360 and the area. So it's actually a nice little, pretty short formula for us. It's just the measure of our arc over 360 times pi r squared. So as long as we know both of those things, we know the measure of our arc and we know our radius, it just becomes a plug and chug formula for us. So if we want to look at our first example here with sectors, it asks for the area of the sector GPH. That's kind of what's shaded in here in yellow. And it does tell us to leave our answer in terms of pi. So I'm going to start by writing down my area formula. And area for a sector says take the measurement of the arc, so our arc here is arc GH, over 360 times the area of the circle, which is pi r squared. And if you think of it, what this area of a sector formula is saying is we're just going to take a fraction of the area of the whole circle. We're going to take the fraction of that arc of that whole area, which makes sense. Again, think about your slice of pizza. Your slice of pizza is just a fraction of that whole area of the pizza. So just kind of a way to maybe help you memorize that formula if that's something that you're interested in doing. So now we're going to plug and chug the measurement of GH. Measurement means degrees. We're not talking about length here. We're talking about angle measure. So we've got 72 over 360 times pi, and my radius is given to me as 15 here, 15 squared. Oops, I missed my square there. Now, we want to leave this in terms of pi. We need to simplify everything but the pi. So remember, 15 squared is like taking 15 over 1, and when we're multiplying fractions, we multiply across the top and across the bottom. So I'm going to take 72 times 15 squared, then divide by 360. So in my calculator, that looks like this. 72 times 15 squared is a function over here in the upper left-hand corner. Yours might be in a different position. Make sure you hit enter because 225 is actually just 15 squared. That's not times 72. Then divide by 360, and we get 45. So we've simplified everything but the pi, so we leave pi in our answer. 45 pi centimeters squared. We are still talking area, even though we're looking at a sector. Make sure you use units squared. Let's try one more of those before we move on to our last topic for this section. says a circle has a radius of 4 inches. What is the area of a sector bounded by a 45-degree minor arc? And again, leave your answer in terms of pi. So we have everything we need here. Remember, we only need two things to use this area of a sector formula. We need our radius and we need our we need our arc measure. In this case, we've got a 45-degree arc, so we're going to take 45 over 360 times pi times my radius, which is 4, squared. That's just straight plug and chug. Again, leaving it in terms of pi, we want to simplify everything but the pi. So we're going to take 45 times 4 squared. Make sure you hit that enter button. And then divide by 360, and we get 2. So don't forget to include the pi. 2 pi, my units are inches, and we're talking area, so it's squared. So pretty straightforward. Your homework problems are going to be very similar to that. You do have one where you'll have to work backwards to find the radius, so you'll be given the arc and you'll be given the area of the sector, and then just plug in what you know and work backwards to solve for the radius. Now, our last new term for this chapter says a part of a circle bounded by an arc and the segment joining its endpoints is what we call a segment of a circle. And we have an example over here on the right. This kind of shaded in yellow portion is my segment. Now, as is, it doesn't really look like anything we know, but if we want to draw in our radii that connect those endpoints, notice it kind of looks like it's our sector, our slice of pizza, except for we're subtracting off a triangle. So I like to think of this almost as kind of like maybe the crust of your pizza, but really it's just your pizza minus a triangle. And we see that demonstrated down here in our next key concept, where we're looking at finding the area. So just like we just talked about thinking it maybe as that crust, we're going to take our sector and we're going to subtract off a triangle. That's all we really do to find the area. Find the area of the sector, then find the area of the triangle, and subtract that triangle off, and that's going to give you the remaining segment. So let's look at one last example here to wrap up our notes. We want to find the area of the shaded segment at the right, and we want to round our answer to the nearest tenth here. Now in your homework, all of these you'll be able to round. My best suggestion though is to try and give yourself as many digits as you can until the very end so that your rounding is as precise as it can be. So let's start and remember to find the area of a segment, not triangle segment, area of a segment. We need to find the area of the sector and subtract off the area of the triangle. I keep wanting to do it triangles is my A. So let's start by finding the area of the sector. That's what we just practiced in our last couple of examples. And the area of a sector is that fraction of the whole. So what we're finding here is we're like finding all of this. We're including that triangle. All of this is the sector. So we're going to take our arc measure, which I just covered up. If my central angle is 60, my arc is also 60. So 60 over 360 times the area of the circle, pi. My radius is 18 squared. And again, we're going to round here, but I'm going to give me a good number of digits to make sure that I get a close final answer. So I've got 60 over 360 times pi, which is 3.14, times 18 squared. And again, don't forget to select enter. So I'm going to go ahead and write this down as 169.646 inches squared. So to get my area of my segment, the yellow shaded region, I need the sector and I need the triangle. So let's find the area of that triangle next. Now, our typical area for a triangle formula is 1/2 base times height. And if you look at your homework example problems or in the textbook, they're going to take the time to find that. Since we're able to round in this case and we don't need an exact answer, I'm going to go ahead and use that formula we were introduced to last week that says that the area of a circle, the area of a triangle is also equal to 1/2 BC times sine of A. If you look at this triangle here, I'm going to go ahead and highlight it in purple. In order to use that special area formula, we need to know side, angle, side, two sides in the included angle. Well, I know side CB is 18. I know angle C is 60. But if you think about it, this is an isosceles triangle since CB and CA are both radii. So CA is going to have a measure of 18 as well. So I'm going to use my formula 1/2 BC, those are my two sides, 18 times 18 times sine of my angle, which is 60 degrees. And I'm going to throw that whole thing in my calculator. If you need help with that formula, please let me know. 1/2 times 18 times 18 times sine of 60 in my calculator. Do 60 first, then sine, then make sure you click enter. And again, I'm going to go ahead and do at least three decimal places here. 140.296. And I'm still talking inches squared. So what I just found was this kind of shaded region, purple here. So to find the yellow region, the segment, I need to take that area of the sector and subtract off the triangle. So the area, and there I did it again, I did a triangle instead of an area of my segment is equal to the area of my sector, which we said is 169.64, minus the area of that triangle, 140.296. Last step, throw that in our calculator. And we get 29.344. It does want us to round our final answer to the nearest tenth, so we've got 29.3 square inches. So again, as long as you're able to round, go ahead and use that shortcut formula for the area of the triangle, 1/2 BC times sine of A. But your homework example problems will show you a different route to actually find the height, so you can do 1/2 base times height. I think it's faster to use your sine formula, but you can go ahead and decide either way you want to use that. If you have any questions on areas of circles, segments, or sectors, please let me know.